going along, let's start with the concept of inheritance. Inheritance indicates that we want to extend the features of one class into the other class. Let's assume whenever we are born, we inherit some features from our father and our mother. So our father and our mother are our parents. Okay, the similar concept comes in Java as well. Inheritance indicates you are extending features of one class to the other class. The class which is extending the features is called as the child class or the derived class. The class from which you are extending the features is called as the base class or the superclass or the parent class. Now, what is the advantage of inheritance? Suppose that we want to create one more class called as first year student. Now the first year student will have all the features of the student class, plus it will have some more features. The student class had 5 features: name, roll number, address, contact and branch. First year student will also have a name, a roll number, a contact, address and branch, plus it will have some other information like the percentage in 12th, etc. So suppose we want to make a distinction between first year students and regular student, then we would have to make the student class as the base class for these classes. That is, the student class will be the parent class and the first year student class and the regular student class will be the child class or the derived class. So both first year student and regular student would have the same members as of the student class and some more extended members as follows. Let's try to write the class first year student.java. We'll create a new class in Eclipse called as first year student with the name first year student, and we'll say class first year student extends student. Extends is a keyword. This keyword indicates that the class first year student is a derived class and the class student is a base class. In other words, the class first year student is a child class, whereas the class student is the parent class for the first year student class. So with this single statement, first year student class will exhibit all the properties of the student class plus some of its more properties. Let's add some more properties to the first year student class. We have public string section that indicates that the first year student has a section A, B, C, D, E, F, and a float percentage in 12th. Whenever a student comes into first year, he comes from the 12th class, so we have a percentage in 12th. That's it. So the first year student class now has 7 members, 5 from the student class and 2 new members of the first year student class. That is fine. Now let's move towards the regular student class. Let's have a class regular student extends student. So we have to create a new class in Java with the name regular student, and as soon as we say extends student, this indicates that this class will be an extension of the student class. This double slash indicates a comment, and we are saying in the comment indicates percentage in first year of the Polytechnic. So we have a float qualifying percentage. The float qualifying percentage indicates that this regular student class has all the 5 members from the student class plus 1 member called as qualifying percentage of its own. So thus such a student would have a qualifying percentage of the last exam pass. That's fine. The slash is used for commenting, just like in C. Now let's see an example of inheritance. We'll create a regular student and a first year student and fill the given details, and we'll print the same in the next section. So let's try to do this thing. In inheritance, we have to create 2 new classes, first year student and regular student. So how do we create a new class? We right click on the source folder and say new class. Let's give the class name as first year student. Okay, one point to note over here is all the class names must start with a capital letter and must follow camel casing. Okay, the meaning of camel casing is every word that you type in the class name must start with a capital case. For example, first it it was the first word, so we had F capital. After first we had year, so we kept Y capital. After year we had student, so we kept S capital. So this indicates camel casing, first year student with F capital because it is the first word of the class name. Press finish. It will give you public class first year student. Now what we want to do is we want to make first year student as the derived class and student as the base class. To do this, you have to just say over here extends student. This will indicate that first year student class is the derived class, student class is the base class. Now first year student class has all the 5 properties of the student class, plus we have to define some more properties. So let's define it over here. Let's say string section and say float percentage in 12th. You can give big names to variables because you don't have to type it after this. You have to just press a dot. When you press a dot, it will directly come in the list. You can pick from the list. We have to now create one more class. Let's say create one more class. Right click, new class. The name of the class is regular student. Then regular student is also a derived class, so I'll say extends which class? Student class, because a regular student is a student, but it has one more property. The property might be qualifying percentage, right? So I'll say qualifying percentage. So let's define that float qualifying percentage. Okay, now this double slash indicates this is a comment and this float indicates this is a float variable. Let's try to access all the properties of these two classes in the test class. Over here I'll remove everything from the test class so that we get a blank class to work with. Over here let's first create an object of first year student. How do we create the object of first year student? By saying first year student, that is the class name. Let's give the object name as fys. So I'll say first year student fys equals to new first year student. This indicates that we have created an object of first year student. How many properties we have in the first year student object? We have these two properties from the first year student class and all the 5 properties from the student class. Okay, we don't require the ID. I'll just remove the ID from here. Let's come to the test class and let's try to access these properties. I'll say fys dot name equals to Rahul, fys dot branch equals to IT, fys dot roll number equals to say 23, fys dot section. Now see, this section isn't defined inside the first year student class, so I can access that. Let's say section is A and let's say fys dot, I'll just type P, it will give me the percentage in 12th equals to 98.5 F. F indicates this is the floating point variable. If you will not write F, it will give you an error. So we have to give an F. F indicates this is a floating point variable. Let's try to print this thing out. How do we print the thing out? By saying system.out.println. We can type the complete thing or we can type syso control space. That indicates this is a shorthand for the command system.out.println. Let's give over here my name is plus fys dot name. Fys is an object of the class first year student plus I scored, let's give plus FYS dot percentage, let me give percentage sign, in 12th class. Okay, so this will give the output, my name is Rahul, I scored 98.5 percentage in 12th class. I'll just right click on the test class and say run as Java application. As you can see, it gives the output, my name is Rahul, I scored 98.5% in 12th class. This was a basic example of inheritance. What you can do as a homework problem is, you can create an object of regular student class by saying regular student rs equals to new regular student, fill in all the properties of that object and try to print all the properties. After finishing inheritance, let's move towards polymorphism. First of all, let's understand the meaning of the word polymorphism. The meaning of poly is many and the meaning of morphism is forms. So if an object can exhibit many forms, then that object is called as a polymorphism or a polymorphic object. So if an entity is possessing many forms, it is supposed to exhibit polymorphism. To demonstrate the use of polymorphism, let's define one function inside the regular student and the first year student class. Let the function name be print details. Now how do we define a function? We say public void print details. Here the meaning of public is it is visible to everyone. The meaning of void is that this function will not return anything. The meaning of print details is the function name is print details. Here we will say system.out.println I am a regular student. I hope we are clear with the syntax now. System indicates a computer system. .out indicates the output device. .print indicates we want to print on that device and leave a new line. So this, whenever we will call this function, it will give the output as I am a regular student. Let's define one more function in the first year student class with the same name. We have public void print details system.out.println I am a first year student. In student.java, let's have the same function print details and we'll say I am a student. So in all the three classes we have the same function with the same name, but it has a different implementation. Means in the student class we have print details that print something. In first year student we have print details that print something else, and in regular student we have print details that print something else as well. Now in the test.java class we will write the following code. We'll say student s equals to new regular student. Now this syntax might be a bit new, but we'll first understand the syntax. Whenever we say student s, that indicates that s is an object of student class, and whenever we say new regular student, this indicates that you create a new object of the regular student class. Now this new regular student is an object of type regular student, which is a derived class of the student class, because regular student was a derived class and student was the base class. So the object S, being an object of the student class, can contain the reference of the regular student class. That indicates that if an object S is of the base class, it can contain the reference of the base class as well as it can contain the reference of all the derived classes. For example, student is a base class, regular student is a derived class. So when we say student S equals to new student, S being an object of the base class student can contain the reference of the object of the regular student class, that is the derived class. So whenever I'll say s.print details, the compiler will first search for the function print details inside the derived classes. If it finds the function inside the derived class regular student, then it will print that out, else it will print the function from the student class. So if we run the code and check the output, we'll get the output as I am a regular student. This is polymorphism. That is, we can create an object of the parent class and store inside it the reference of a child class. Suppose, now this is a bit of a warning. Suppose that there was no method called as print details inside the regular student class. That is, print details was not present inside the child class. Then the method print details of the student class would have been called. Okay, so even if the method print details was not present inside the regular student class, the compiler will first search that method in the regular student. It will not find that, so it will call the function inside the base class, that is the student class. So whenever the child class implements the method of the same name as in the parent class, then it is called as a overloaded method, and this process is called as function overriding. Okay, let's come back to our class again. In this case, regular student contains the method print details, first year student contains the method print details, student contains the method print details. So first year student is the child class of student class. It is implementing a method print details with the same name. Okay, so this is called as function overriding. This simply means that the child class wants its own implementation of an already implemented method. Okay, so this is how polymorphism goes. This concept is very frequently used in all object-oriented programming languages, especially in Java. So let's take an example of polymorphism. We'll create a bike class with bike name and gear as two variables and a print details function. Let's create a child class to this bike class and name it as Activa. Let's have a top speed as a float variable and have a print details function. We'll create another class to this bike class called as unicorn class, and it will have another variable called as gears and a function called as print details. Okay, we have to create a test bike class to test this polymorphism. So let's do it in actual practice and see what is the result of this. So let's do it for polymorphism example. In polymorphism, we'll be requiring a function with the same name inside all the three classes. So let's define the function public void print details. Let me print this out. I am a student. Okay, so whenever we'll call the print details function with a student object, we'll get the output as I am a student. Let's copy this function from here and paste it inside regular student. I'll say I am a regular student, and first year student, paste it inside this and say I am a first year student. Let's go to a test class and remove everything from here. Polymorphism means one thing in many forms. So if I define student s equals to new student and try to print s.print details, it will give me the output as I am a student. Okay, that's very fair enough. It's very simple. Now if I will say student s1 equals to new first year student, I'll say s1 dot print details. It will give me the output I am a first year student. Okay, so appreciate the fact that s1 being an object of the student class can contain the reference of student, of first year student, or of regular student. That is, the type of object is same, but it has many forms. That is, it can take the form of a student, it can take the form of a first year student, or it can take the form of a regular student. So if I will say student s2 equals to new regular student, try to print this thing out, s2 dot print details, right click on test, run as Java application. It will give the output I am a regular student. This basically indicates that the type of object is same, but it can contain all the types of the derived classes, like student S1 equals to new first year student. First year student is a derived class, student is the base class, so S1 can contain the object of either a student class or a first year student class or a regular student class. That means one thing in many forms. This indicates polymorphism.